This is Judy with Real Time with IPC on the floor of APEX EXPO. Today is my honor and delight to be with John Ranieri of Rogers Corporation, who is a business development manager. And today we're going to ask John about Rogers and what's new and what's going on here at the show. So welcome, John.
Thank you, Judy.
For folks that don't know, just give us a quick overview of the laminate and circuit materials that Rogers manufactures.
Sure, yeah, so Rogers is a global specialty materials manufacturer. We focus on engineered solutions for specific applications, and I'm part of the Advanced Connectivity Solutions division, and we really focus on printed circuit board materials, so that's laminate and pre-preg materials that make up the substrate of the printed circuit board.
Right.
We've been a leader in the RF market space, and we're now working on moving into the power electronics market space as well.
So tell us what you're highlighting here at the show.
So we're highlighting the 92 ml series of thermally conductive epoxy materials. And this again serves the power electronics market. In the power electronics market, what's really important, it's a little bit different than RF. We're talking about here routing and converting power rather than RF signals, right? And so what's really important is thermal management. These boards get very hot because the ICs involved are routing a lot of power. And so what designers do is they use a lot of different techniques to manage the thermal performance. The techniques involved are like heat sinks, heat pipes, different types of thermal spreaders like graphite spreaders, for example. And in some situations, they actually use active cooling. So that would be like putting a fan across the circuit board, or maybe using some sort of a liquid cooling with a heat exchanger. And the issue with all these different types of thermal management techniques is that, first of all, they're costly, of course, and also they add a lot of weight and a lot of bulk to the circuit. So you have a regular circuit, and then you're putting something else on it in order to manage the thermal performance. Our solution is 92 ml, and 92 ml is actually a thermally conductive PCB material. And that material actually has a high thermal conductivity. It's like 2 watts per meter Kelvin in the z-axis and 3.5 watts per meter Kelvin in the x and y-axis. And what that does is it conducts the heat through the circuit board, and it actually spreads the heat out over the surface of the circuit board. So that allows you to keep the junction temperature very cool without adding any additional cost or weight or taking up any additional space.
So in the power electronics market, what specifically, I'm thinking maybe automotive, but what other applications specifically have those high power applications?
Yeah, well, you definitely hit on one general market, which is the automotive market. Within there, automotive has challenges with weight and space, of course, and cost, so all three, and then you throw in reliability as well. Right. So reliability is extremely critical. The issue is that everything that you put into a car has to be put on the car, and then it's driven around for hundreds of thousands of miles. So every little bit of weight or space is critical. So within automotive, we see a lot of activity with electric vehicles and hybrid electric vehicles, and the number one application there would be power converters. This takes, like, for example, a DC to DC converter takes a 12 volt power and changes it to 48 volts, for example. The other area in automotive is electronic control units, and these are the computers that essentially run cars nowadays. Your car is essentially a computer. As well as routing power to various functions. So those are the two applications there. The third I'd mention is LEDs. So LED lights all generate quite a bit of heat, and typically in LEDs what's used is what's called IMS, which is insulated metal substrate. All it is a one-layer circuit board that has a dielectric, and then it has aluminum underneath. So it's a plate of aluminum that acts as a heat spreader. And the last application is actually consumer electronics. So in handhelds and wearable devices, the outside case temperature has to be close to the temperature of your skin, like 37 to 40 degrees Celsius. And so, when the CPU is running very heavily, you're playing a game or you're maybe using a camera, the temperature of the ICs inside increases, and you have to dissipate that heat somehow. And so that's another application that we see using this.
Sounds like a really broad market and timely.
Yeah. It is. Yeah.
So good luck here at the show. Where can folks go to find out more about the 92 ml and the things that you're rolling out here at the show? And
yeah, I'd suggest starting at our technology support hub. So that's at rogerscorp.com/techhub, TECHUB. And there you can find articles and videos, white papers and data sheets, all of the information that you need to learn more about the product.
Great.
And if you want, you can contact a sales engineer that will help you, with the design of your product as well through the tech hub.
Okay. Well, thank you very much. It's been great to catch up with you, and good luck with your show.
Thank you.
And the 92 ml.
Thank you very much.
This has been Judy Warner with Real Time with IPC and John Ranieri of Rogers Corporation.